Hello again, Miss Jody here with our second video for Earth and Space Science. And hopefully you were able to watch the first video where we talked about what we're going to be trying to do to keep up with the journals. Now I know that we already have some extended time that we're going to be separated, but I still think we could do our journal pages, and that way we don't end up not being able to finish our journals, even if it takes a while for me to glue them all in when we get back together, or maybe I'll do a drop-off time since I'm here at the center each day where you can just drop them off in a drop box and I can continually glue them in as you work on them. Something like that. But in the first video I explained that we're going to take a little half sheet of paper, computer paper or whatever, and that's where you will take your notes, and that way I can glue it right on the page underneath the label that it matches. So the best thing to do would be to write the label title on the back of the page so that when I go to glue them in, I know which one goes on which page pretty easily. It'll make it faster for me. Okay, so we are continuing on in our study of space, and as you remember, we've been spending the entire year studying Earth because this is Earth and space science, and then we finally were finished with understanding Earth and all of its systems, and then we had to turn our eyes upward to look at everything else that's out there. Now, last video we looked at our particular solar system and how small we are, how big it really is, but how small it is in comparison to everything else out there, and just kind of did a tour of the solar system, looking at the planets, the asteroid belt, the little bit with the Kuiper belt and the theoretical Oort cloud. Now we're going to look at some other things that exist in our realm of space that we've been talking about, and that's going to be asteroids, comets, and meteoroids. And then we're also going to look at constellations. Okay, so getting started with this tab, it's going to be the three topics of the tab: the asteroids, the comets, and meteoroids. So we'll start with the asteroids, and I'll try to move this a little bit so you can see. My book is getting so thick that some of the notes are over here, a little hard to see. All right, so if we look at the first one, the asteroid. So what's an asteroid? So this is going to be a stony or metallic object that is smaller than the planets and actually orbits the sun. So it's still going to have an orbital pattern, but it's going to be smaller than the planets, and it's going to be, as we see, many asteroids are in our own solar system and probably other solar systems out there around other stars. So there's going to be a variety of shapes and sizes. So they're not all going to be like perfectly round, and we see a lot of the planets being more round-like, and actually the larger asteroids, a lot of them are more round. But some of the smaller ones, and just depending on different sizes and shapes, we have a whole variety. Some look like potatoes, some are really a little bit smaller, some are a little bit bigger. They're each going to have their own specific orbit. Now, some of them, as we've studied before, are going to be in the asteroid belt. So there is an entire belt of asteroids that are going to be circling that we've already studied. So many of them will be there, but then there's some that aren't in the asteroid belt, and these are going to be still in the solar system but traveling differently. Like for instance, we have the Trojan asteroids. Now these are the asteroids that are going to be interacting in Jupiter's orbit. And so what's interesting about these guys is there's a whole big group of them that's 60 degrees in front of Jupiter orbiting, and then the whole another group of them 60 degrees behind behind Jupiter, and they're in that particular orbit. And I'll show you this. There's a diagram that I sent, two half-sheet diagrams, all saved on one page for you to print out if you can. And if you look at this top piece, it's kind of hard to see, but I'll try to illustrate our sun here. Let me get a little yellow. Okay, so the sun being right here, this little dot in the center there. You see it's so small. So basically this is a pulled out view of the solar system from the top, kind of looking at it and the different planets going around. I'm going to try to bring it up a little bit closer there. So you see that little dot? So that's going to be the sun. And then all of these little dots you see all around here, this is what we would say is the asteroid belt. So near that sun, we have Mercury, Venus, Earth, Mars. Then you remember the belt is there. So look at how many is illustrated in this little diagram. Well, if you look at outside of the asteroid belt, the next planet is Jupiter. So here's Jupiter, and you'll see it on your diagram, and then you'll see these little areas of those dots also. So there's some here, and some before it, and some behind it. So that's what I'm talking about. That's so not just the ones inside the asteroid belt, but also some of these asteroids that are in other places, like this one, these two packs particularly orbiting with Jupiter. And so we will find, and let me highlight that a little bit here, them and these areas. So I'm going to just highlight this is like the big asteroid belt with lots of the asteroid side of things, right? And then we've got these little ones over here, the Trojan asteroids that are in this orbit with poor little Jupiter here. Okay, so we have those types of asteroids too. And then we also have some asteroids that we call NEA. So NEA stands for near Earth asteroids. Any of the asteroids that are near the Earth. And if you look on this diagram, and maybe let me see if I can give Earth a little blue color. So since it's so water-based, sorry about bouncing the picture around there. Let me see, I can barely see it. Sun, Mercury, Venus, Earth. There he is. Okay, so see, I tried to make Earth a little blue there, you see? So that is Earth, and so this is the asteroid belt, not too far from it, right? Because the next one after Earth would be Mars. So any of them that are going to be in this closer circle, getting closer to Earth, would be what we would call the near Earth asteroids. Now with asteroids, a lot of things can happen, and we can have things like collisions, and where asteroids can collide and break up into smaller pieces. We can also have their orbits disrupted by planets, and so the planets can disrupt orbits of the asteroids, and some of them can actually pull them out of their own orbit into theirs, or these asteroids can be thrown out completely out of the solar system in a disruption. So depending on what goes on with these guys, we can have some movement, but they do originally have their own specific orbit, but it can be disrupted, and there can be those things that happen with the asteroid world. Now, with this diagram, just trying to put a little color and some fun onto things, I'm going to just draw a couple weird shapes just to remember the asteroids. Now, these are our markers from the upstairs classroom, so who knows if they'll work, right? We try to get some new markers in here soon, definitely before camp season, but let's give it a try. Okay, not too bad. So I'm going to draw me a weird little potato one, and this is something you can do at home. This just helps bring a little bit of color to our pages and helps us get done with our diagrams. And of course, save these diagrams if you print them out and you get them all done, because then I'll glue them into the spots in the journals, okay? So I'm just making a little potato looking shaped one. And don't forget that because of the impact sometimes on these in the collisions, we have the craters on some of these asteroids. So that was kind of a potatoy looking guy. And some of the bigger ones, let me try to draw a bigger one here maybe, okay, getting a little bit more round, and then I'll put a little, color him in. And so you can just imagine and use some visuals from your book. It shows you a couple of them, specific ones, to draw some asteroids over here, okay? So the asteroid world. Put some little craters on this guy and little craters on that. And then, of course, that being next to this particular diagram, that is showing us that it's not just asteroids within the belt, but then also in other places they can be found. Okay, so then the next one, and each, you can see on this diagram, there's going to be one little diagram for each of the three topics. So the next one is the topic of the comets. So the comet is an asteroid-sized object that is made of rock and frozen materials. So when we started looking at the comets, we realized that there's a lot going on here, and that these particular space objects were in their own particular orbit. Now, Tycho Brahe, if you remember him when we were studying Kepler's laws of planetary motion, he was the guy that did a really good calculations, that Kepler used his calculations to kind of figure some of these things out. And so in 1577, he started looking at these comets. Now, up until that day, they thought of the comets as being invaders from outer space and didn't really understand what was going on. And then he suggested with his calculations that they were actually part of the system, which would be our solar system, and that they are in orbit, and sometimes they would disappear. So they thought, and then new things would arrive, and they thought they were invaders. But the reality was it was just their orbits were a lot longer. And so of course, Sir Isaac Newton also started studying them, and he came up with the same orbital laws of motion that we're seen in the planet. So he says, yeah, hey, these things they're doing a similar thing that we see these other things up in space are doing. And then Edmund Halley, this was a gentleman, sometimes he's named Edmund with a U, but he was studying, and he was looking at some records of comets in the past. And there was a comet in 1682 that he was studying, and these two other comets that were seen in 1531 and 1607, the descriptions seemed to match what he was seeing with his comet that he was studying there. And so he predicted that they were probably all the same comet, and that it was just a really long orbit, and that when it came back around, it should be about the same amount of time. Well, in between this to this year is 76 years, and in between this year to this year is 76 years. So he predicted that it would reappear in 1758. And he was correct, and it got named Halley's Comet because of that. Now, he did not live long enough to see that, but he definitely was right. So when it comes to the comet world, we have a little focus on the way that the comet is built, okay? And so the specifics of the comet, I have a little diagram, but we have the nucleus, okay, which would be the center, just like we would say with an atom. We've got the nucleus of something, and they say it's about 2/3 of the whole nucleus is ice. Now, when we look at ice, and we've talked about this before, ice doesn't mean water all the time. Ice is a category. It just means that frozen solid form. So H2O can be ice. We can have carbon dioxide as ice. We can have carbon monoxide as ice. We can have methane, which is CH4, as ice. So we have all these things that can be ice, okay? So, but 2/3 of that center, that nucleus of that comet is going to be ice. And then 1/3 is, they're suggesting, is the dust part of it. And that, all of this coming together is compacting into this solid mass. And so these comets, as they're going along, and you've seen this before in pictures, we've got the nucleus, and I'll go ahead and try to do a little center here, okay? So this will be like the nucleus, the big mass, the center of that guy. Now, as he's getting close to the sun, and what I'm gonna have to do is I'm gonna have to draw in here like a visualization. Well, that was terrible there. I don't know what's happening with that, but we'll pretend like that's okay. And so I've got my little sun. This is like just half of a sun, okay? I've got my sun, and as my sun's going through its process that we talked about of nuclear fusion, we have, and I'm just gonna make my sun very just bright. And this is something you would do with your colored pencils or your markers at home. So as my sun is going, we know that through that process of fusion, we have all of these bursts of energy coming towards us. And when the comet is going to be in the presence of getting closer to this energy, it's going to start to melt, right? And as it starts to melt, we have this outside, which we'd call the coma, this blurred stuff around it as it's going through its melting process. Now, when the sun is spitting out all this, like the sun loves to do, sometimes we have those really big bursts of solar flares, which are the solar winds. Remember we talked about this before? And it will get so violent, it will spit out, and these particles are flying, and they are able to actually move the stuff coming off the comet as it's melting. So as it's going through its melting process and then going into its gas form because it's so much energy, then it kind of has this like steam look to it. And when it's coming off, we call that the tail, right? So this is the tail of the comet. And then these energy particles are pushing all the stuff that's flying off of it. This is why the tail ends up going that direction, right? So the particles are pushing it off and moving it that direction. So it looks like it's kind of going through the sky with this little tail. And the tail will end up separating a little bit for visual purposes. And this dust tail side of it, where the dust is coming off, it'll kind of stay like a color that's similar to the light of the sun, because it'll react with the sun or interact with the particles as it's coming off. And as we know, light, depending on what it hits, it can cause us to see it different colors. And the gas side of it, so this will be kind of like a whiter light, and the gas tail part of it will kind of be bluish, and that's because the gases interacting with these particles will give off more of like a little blue light. So it kind of separates this gas and dust cloud into kind of two colors sometimes, the way you're viewing it. And so that helps for us to understand that part of it. Then the last one for this one is meteoroids. Now the meteoroids, they're small chunks of rock and or metal, okay, in space. Now, this is what's important for understanding about meteoroids, okay? So these are the things that are in space. It's not really about size, because sometimes when you get a real big one, a scientist might call it an asteroid, other scientists might call it a meteoroid. What's really important with understanding the terminology is that it's not in Earth's atmosphere, okay? So it's anything, these small chunks of rock or metal in space that are out and they have not entered the atmosphere, the orbital, the layers, our blankets, right? And so it's not really about size or shape. Once it does enter the atmosphere, it becomes a meteor. That means it's entered the atmosphere. Many times that burns up. And then if it actually doesn't burn up and it actually impacts the Earth's surface, we're going to call it meteorite. And I always tell the kids to remember it this way, because it did it right. It hit the Earth. They're all trying to come in and hit the Earth, and the meteorite is the one that actually does it. So if you look at this diagram, and this bottom diagram is just reminding us of those layers of all that wonderful atmosphere, the air sphere laying on us that we have to protect us from everything, right? And so if we, as a memory tool here, I guess that yellow is not going to do me justice. Let me switch to orange here. Okay, so we have, this is us on Earth, and then we've got that first layer, the troposphere, we got the stratosphere, and the mesosphere, and the thermosphere, and then the exosphere. So we got these blankets of air laying on us, and what's so great about that is it's protecting us from things that do want to come in to our Earth. And so when we are looking at these three categories, we can use the layers to help us remember them, okay? So if I say the meteoroid, it's going to be outside of the Earth's atmosphere. So he would be up here, okay? So here's going to be whatever, my meteoroid. So let me put that meteoroid. He's going to not have made it in yet to the 5 layers. And but then if I then say, okay, but the next one would be actually getting in these layers, but burns up, would be the meteor. And I can put a little burning up on him once I color him. And then the third one would be the meteorite. And see, here's the Earth right here in the layers. So I want to make sure that I put him impacting the Earth there. And that will be my meteorite, who did it right. Not that I want anything to hit our Earth, right? So let me get my little meteor here. He's flying around, so we don't need to add any burning going on him because he's outside of the atmosphere. But once they enter the atmosphere, as they're coming towards the Earth, there's so much impacting of the air in those layers that it's knocking into the air layers, and it's creating so much friction that it's going to end up starting burning up because it's so much heat as it's hitting all of those air molecules because it's inside the layers. And then of course eventually he will burn up. So I'm just going to put eventually burn. I'm going to just cross him out because he won't hit. But this guy, the bottom guy, he actually will hit because he's a meteor, right? Who did it right. And I'll still give him because he's still going to be burning up, or he's still going to burn up as he's going down. So he's going to lose some of his mass, but then eventually he actually will hit the ground. And when he hits the ground, then we sometimes have a meteorite impact and we'll get a crater going on there. Okay, so that will help us visualize, and again, do this with your colored pencils and your own markers at home so you can keep track of the 3. This guy's not burning because he hasn't entered. This guy burns up, and then this guy is burning as he's falling, but he actually still has enough mass to make a hit, and he becomes the one who does it right. Okay, all right, so I'm going to stop the video. Even though we have constellations, I'm going to do a separate one on that so they're a little shorter, okay? So you have 2 videos this week to look at.